Here is a little mystery before we start. Here is a mental math trick. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 9, and our lesson is all about algebraic identities. Before we start, a quick recap. In our last lesson, day 8, we studied factor theorem, statement, proof, factorizing using factor theorem. If any of that feels unclear, pause here and re-watch day 8 first, because today builds directly on it. By the end of this lesson, student can recall and apply standard identities by understanding their geometric area proofs. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. Here is a mental math trick. How do you calculate 102 squared in your head? Doing 102 times 102 the long way is painful. But if you think of it as 100 plus 2 squared, you can use an algebraic identity to solve it in seconds. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? Most students hate algebraic identities because they look like random letters to memorize. But they aren't random. They are universal physical truths. For example, a plus b squared is literally just the area of a large square that has been chopped up into for smaller pieces. When you see the geometry, you never have to memorize the algebra. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today, all standard identities with geometric proof. In symbols, we write it as a plus b all squared equals a squared plus 2ab plus b squared. Every word of that definition matters, so read it slowly. You already know expansion of brackets, polynomials, basic area of squares. This definition simply builds on those familiar ideas. Here is the key formula for algebraic identities. The formula is a plus b all squared equals a squared plus 2ab plus b squared. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Expand x plus 3 squared. Use the pattern first squared plus 2, first, second, plus, second, squared. Equals x squared plus 2, x, 3, plus, 3, squared. Equals x squared plus 6x plus 9. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. The most famous mistake in all of algebra, claiming that open parenthesis a plus b close parenthesis squared equals a squared plus b squared. This completely ignores the two AB rectangles in our visual. Emphasize that the exponent does not simply distribute over addition. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Mental math, 102 squared equals 100 plus 2 squared. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. Equals 100 squared plus 2, 100, 2 plus 2 squared. Equals 10,000 plus 400 plus 4 equals 10,404. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits algebraic identities. We explored all standard identities with geometric proof. The one formula to remember is a plus b all squared equals a squared plus 2ab plus b squared. Watch out for the common trap we discussed. And remember our goal: student can recall and apply standard identities by understanding their geometric area proofs. Next lesson: Cartesian plane, axes, quadrants, and plotting points intuitively. New lessons every day on Math Concepts Made Easy. Thank you for learning with me. See you tomorrow.